Thank you so much, Tim, for those kind words. I'm really delighted to be here for many reasons, one of which is my husband's family is actually from New Orleans. So we are down in New Orleans as often as we possibly can be. It is such a fantastic city. It's so wonderful to be here in the Roosevelt Hotel with its amazing historical ties to the great city of New Orleans. So thank you very much to Tim. Thank you to Bill Azell for inviting me to be here today. It's wonderful to have a chance to talk to you all about what I do and what software can do to change all of our lives. My job is a fantastic one. I get to work with some of the most innovative companies around the world. And by doing that, I have really had the opportunity in the last couple of years to be inside a revolution that is happening inside the industry, but is going to have an impact on the world around us. And so I want to talk a little bit about that revolution today. But before I do that, I want to start by taking a moment to tell a story from the other side of the world and step back in history a little bit. So picture yourselves in London in the 1850s. And it's an unhappy time in London. There's a cholera epidemic that is ravaging the city. People are completely terrified. Thousands of people are dying. People are starting to flee London as a city. And the scariest thing is that no one knows why. No one knows why people are dying. No one knows how the disease is being spread and how it's contracted. The most popular theory at the time was that cholera was spread by something people called miasma, which is basically the clouds of fog that randomly drifted through the London streets. But there was a doctor, a man named Dr. John Snow, who came up with an idea. And at the time, it was a very new approach. And what Dr. Snow did was he put a map on the wall in his office, a map of London. And every time he heard that a new patient had contracted the disease, he put a dot on that map in his wall. And he did that over several months. And as he did that, a pattern for the dots began to emerge, a pattern that had existed the entire time, but no one had seen it until he had started collecting data on this map. And the dots showed that the outbreaks were clustered in a particular neighborhood in London, a neighborhood called Soho. And in fact, as more dots added, it became clear that it was not just this neighborhood in Soho, but that the dots were clustered around one particular corner in this neighborhood in Soho. So they went to that, and they found at that corner there was an open well pump. There was a water source that people from the neighborhood were using. And Dr. John Snow informed the public health authorities of what he had found, of this pattern that he had found, and they shut the well down. And the disease stopped. And they didn't actually know why. And modern germ theory was, at that point, several decades away from even beginning to be well understood. But they knew that they stopped the disease. And in collecting that information and finding that pattern, he eradicated a disease in London that had been killing thousands of people, and he saved thousands of lives. Let me bring you back to the future for the moment. I'm sure all of you have read about and heard about the terrifying Ebola outbreak that we had recently. That was also terrifying. People were also fleeing their homes and very scared about where the disease was going and what the spread was going to be. Today, when Ebola broke out, we had international health organizations from around the world, including the American CDC, go to West Africa to try to fight the disease. But the CDC showed up with something that no one else had, and that Dr. John Snow certainly didn't have. They showed up with a software app. And they used that software app in the field so that when workers were in the field realized that someone had contracted Ebola, they could enter the information and figure out that pattern, but in a way that was much more rapid than what Dr. John Snow could do in the 1850s in London. That app was so critical to stopping the disease and tracking the disease that the CDC called it the Swiss Army knife of Ebola. And earlier this year, as you may know, the international health organizations declared that the Ebola had been stopped and that this app was one of the critical tools in helping that to happen. I tell that story because I think that story is emblematic of the promise that software has today. It can change our lives in ways that are small, but very meaningful to us as human beings, and it can change our lives in ways that are dramatic and even life-saving. Software is letting human beings do incredible things, and we, I think, are really just at the beginning of seeing what the future will hold there. But let me talk a little bit about software in the industry and how we've gotten to the point that we are today. I won't go too far back in time this time, but let me talk a little bit about personal computing and cloud computing and the promise that that holds. So all of you are familiar with PCs, I'm sure. Personal computing brought computing to the masses, a computer on every desk, starting in the 1970s. And I'm sure many of you have seen pictures of the giant mainframes that existed before PCs. So you've probably seen these pictures of mainframes that are the size of rooms and men and women that are dressed in white lab coats, and they're feeding punch cards into these mainframe servers for computation. So PCs essentially eliminated the need for those giant mainframe servers, at least in terms of what most companies were doing. The PCs, personal computers, had sufficient power that companies and individuals could use them on their desktop, they could run their software, and they didn't need to have, they could move much smaller mainframes into their companies. And so they could buy an affordable computer, they could use it at home or work, and that changed the way that we worked and lived in many different ways, including it gave the capability and the audience to allow widespread use of the internet to become possible. And that created entirely new industries. It has changed the way that companies connect with their customers, and it has radically transformed the way that human beings communicate with each other. None of that would have been possible without the PCs. But when companies brought personal computers into their companies, they also brought mainframe servers into their companies. And so in a way, what they did was create private data centers, company by company. And there were many good things that happened because of that. And it allowed companies to have access to software and computing power that had never been possible before. But it is also fairly inefficient for most companies to be running essentially their own private data center. And cloud computing solves that problem. So what cloud computing does is it allows companies to run their software and store their data on or inside of a massive data center that they essentially rent time on. So they're not paying for computer power that they're not using, and they have access to much more powerful computers and servers than they would have inside their own premises. It allows companies and individuals to be able to use software in ways that weren't possible before, and to do it much more cheaply than was ever possible before. So if you think of cloud computing, essentially it's a delivery mechanism for software, but it's much more than that because of the access to power that it lets companies and individuals have. And it allows them to run their software there, but also to store their data there. And that brings me to the second major revolution that is happening inside of software right today. So data and information certainly is nothing new. Human beings have been keeping track of data since the beginning of time. Farmers kept track of agriculture. Sailors have plotted the sun and the stars as they moved around the world. I'm addressing CPAs. People have been keeping track of barter and trade in goods ever since they had the ability to be trading with each other. John Snow was collecting data back in the 1850s. So data information and the value of data information and the value of being able to store it and manage it and analyze it is nothing new. That is something that human beings have been doing since the beginning of time. But here is what is new, what is very new today. And that is, if you look at all the data and all the information that exists in the world today, from this moment, standing here in front of you, all the way back to the beginning of time, to when human beings first started keeping track of information on clay tablets. If you look at that entire span of data, over 90% of it was created in the last 2 years. 90% of all the data that exists in the world today was created in the last 2 years. That is an exponential explosion of data, And that revolution is going to change the way that we work and live in so many ways. First, in terms of just basic impact on the economy, most companies who are using data experience, on average, a 6 to 7% increase in efficiency, on average. If you assume that data and data analytics will start being used by companies on a widespread basis to increase efficiency, and if you assume a very conservative average of a 1% increase in efficiency, and remember the average today is being reported as a 6 to 7%, but if you assume just a 1% increase in efficiency, it is estimated that in the next 10 years, that will add $15 trillion to the GDP. That's the size of the United States economy. That will have massive positive repercussions throughout the United States and throughout the world in terms of jobs and in terms of new markets. But beyond the significant impact that data can have to the economy, it is also being used right now today in all sorts of ways to improve our world. So urban planners around the world are using data to transform transportation systems, to reduce pollution and make it easier to get around cities. Oyster farmers in Puget Sound are using data analytics to measure the salinity in the water and to produce more and delicious oysters. I myself am a huge fan of oysters, and I think what oyster farmers are doing in Puget Sound is something that could be brought to Louisiana as well to great effect and make our oysters here even more delicious than they are today. Doctors are using data analytics in medical research in ways that are really incredible, and there are so many examples here. I could talk for the rest of the conference about what's happening in healthcare and medical research, but I'll give just one example that I have sort of a personal connection to. I have two amazing boys, and one of them was in the NICU for a short amount of time after he was born, in the natal intensive care unit, and happily for our family, he was completely healthy and is completely healthy. But here's an example that I think resonates with me in particular because of probably like any parent, having a child and your desire that your child be as healthy as the child possibly can be. So Canadian doctors working with IBM software started keeping track of the vital points of premature babies that were in natal intensive care units. And like Dr. John Snow, they were collecting data not because they had a particular theory that they were trying to prove, but because they thought collecting the data would allow interesting patterns to emerge that would help with the treatment of patients. And they were completely correct. And in fact, one of the things that they found is that when the premature baby's vital signs stabilized, that was actually a sign of danger, which is completely counterintuitive. And so doctors up until that point, when they had seen the vital signs stabilize, they had understandably lessened the degree of care and monitoring because it appeared that the babies had stabilized. Well, what they found when they started collecting the data was that vital signs being stabilized were actually a risk factor that the baby was shortly about to go into distress. And so, like Dr. John Snow, our doctors today don't still know exactly why that is. But they know that it's the case, and they know that if they see a premature baby's vital signs stabilize, that actually means that they should be giving that baby more care and monitoring it more closely because it is at a high risk of going into distress. And in finding that, they have been able to save the lives of premature babies. There are, as I said, literally hundreds of examples that are happening in the field of medical research right now where data analytics are being used to improve research, improve diagnosis, improve patient care outcomes. But I would also posit that I think we are really at the beginning of what the potential and promise is. It has only been a few years since this field has begun to emerge, and I think it's impossible to sit here today and say fully what will happen. I do think we need to make sure that we all collectively are trying to make sure that we live in a world where software and cloud computing and data can fulfill the enormous promise that they have. And I want to talk a little bit about some of the things that I think will help make that happen. But before I do that, I just want to I want to talk about cloud computing and data and software and how they're all connected, because I think that's not something that's always obvious. And software is the essential ingredient that makes cloud computing and makes data analytics work. So in terms of cloud computing, again, cloud computing allows companies to run their software and store their data in massive data centers that they don't have to own and they don't have to run themselves. They essentially rent time on that. And software makes that happen in two ways. First, the transfer of the data and the software back and forth, in fact, requires software. So data centers are the backbone of cloud computing, and data centers cannot run without software. So in a very fundamental way, software is essential to a cloud computing existing. But even more fundamental than that, the whole point of cloud computing is to allow companies to be able to run software, use more powerful programs, and do it more cheaply. So without software, there's really no point to cloud computing. Cloud computing without software is like a library without books. The whole purpose of it is to allow companies and individuals to be able to use software in ways that they've never been able to do before. With data, in order for data and information to be useful, it needs to be stored. It needs to be translated into a form that human beings can understand and access, and it needs to be analyzed. And in order to do those things, in order to store the data, in order to be able to translate it into something that human beings can use, and in order to analyze it, you need software. All of those things happen with software. So without software, data, much data, is useless. It doesn't matter, and it can't help human beings or humanity do anything without the software. So software is the fundamental core value that makes cloud computing and makes data work. Software is the essential ingredient to those. And that brings me to what I do. And what concerns me as I travel around the world, getting to talk to business leaders like yourselves and to government leaders around the world, and making sure that we have a world that lets us fulfill the promise and the potential of software, of cloud computing, and of data. So first, a couple of things. In order for cloud computing to work, and in order for data analytics to be possible, you need to be able to move data efficiently back and forth between the people that use the data and the data centers that hold the data. And that sounds obvious, probably, but in fact, in many instances, it's not the case. And in order to have a world where data can move around the world, it can cross national borders, and it can get to the people who need it and need to use it, we need to have a clear and predictable legal framework that allows that to happen. And that does not exist today, in part because technology has moved very quickly. As you all know, laws tend to move less quickly than technology, and so we don't have a clear, predictable, international legal framework that governs how data moves around the world. And that causes lots of problems. One of the ways potentially to fix that problem is looking to trade rules. And I think if you look at trade, I think it's an easy question to say, well, what does this have to do with trade, right? We're talking about data moving back and forth across the world. What does that have to do with trade? And I think if you're talking about traditional trade, tariffs and goods crossing borders, you're right. That has, what I'm talking about today has very little to do with our traditional trade rules. But it does have a lot to do with the trade rules for the next century. Right now, as I said, there is no legal framework that governs how data moves around the world. And there is no legal framework that guarantees that the default rule be that data be able to move back and forth efficiently. And that is a problem, and trade agreements potentially are one way to fix it, even though this is not your traditional trade agenda. In fact, as Tim mentioned, at one point I was a trade negotiator. I was the chief trade negotiator for intellectual property and innovation. And what's happening right now around data and cloud computing reminds me a lot of where intellectual property was back in the 1980s. So intellectual property, patents, copyrights, trademarks, fundamental to the US economy, fundamental to the global economy. I think that's very, very obvious as we sit here today. It was not so obvious in the 1980s. And in the 1980s, with the United States at the forefront of this. A group of countries came together and they set trade rules. It's something called the Uruguay Round, which set up the World Trade Organization, which is the preeminent multinational body that governs international trade rules. And in the 1980s, the United States, eventually joined by other countries around the world, recognized that intellectual property was going to be fundamental to our economy and was going to be fundamental to the global economy, and also recognized that there were no international rules governing intellectual property. There were national rules, so countries around the world had their own intellectual property rules, but there was no international framework. And at the time, and so the United States went to other countries and they said, this is a problem. We need to have an international framework for intellectual property. And a lot of countries at the time said they didn't see the need. And they said, and this isn't trade. This isn't goods crossing borders. This isn't tariffs. The United States recognized and pushed, and eventually other countries agreed that this was going to be such an important part of our future that it was necessary to have an international framework around intellectual property rules. And so when the WTO was established, one of the sort of historical things that happened was setting up a framework of rules that any country that belongs to the WTO must abide by around intellectual property. That today takes that for granted, but at the time it was very controversial. And I think we stand at a similar moment in terms of data and cloud computing. We have no international framework. I think it's obvious to me, and I think obvious to many, that this is going to be fundamental to the future of the global economy. And therefore, we need to have some rules that nations around the world can agree on. But we don't have those rules right now. And the United States is, again, at the forefront of going to other countries and saying, this is a place where we need to have international rules. There's a trade agreement right now that's been concluded. It's called the Trans-Pacific Partnership. It's a trade agreement that includes the United States, Japan, Australia, and a number of other countries, all linked by the Pacific. It includes 40% of the world's global economy. And TPP, if it is passed by the US Congress and by the other governments that belong to it, it will actually be the first ever trade agreement to have some rules around data. It has rules that says the default rule is that data needs to flow around the world. The default rule is that governments cannot create their own private internets and try to keep information inside their borders. The default rule is that governments cannot mandate that data centers have to be kept inside of their country in order for companies to be able to operate there. So for us, for software, while the Trans-Pacific Partnership is, like most trade agreements, thousands of pages long and filled with rules that impact every industry sector, for us, and I think for the world, there are a few pages in those thousands of pages that are really critical, and those are the pages that have started to set an international framework for data and the data revolution. And I'm hopeful that our Congress will move forward with passing TPP, and the other governments that have been part of the TPP negotiations will move forward. I think that we are by no means done in terms of setting up an international framework, but I think this trade agreement is at least a start, and a very good start to setting that framework. So beyond making sure that we have rules that allow data centers to prosper and allow data to move around the world and get into the hands of the human beings who need it in order to do incredible things, another thing that concerns me is cybersecurity. And I know this is probably an issue on many people's minds in this room because it is a growing challenge. In 2014, there were 1 million new cyber threats created every day. And on average, every company experiences a cyber incident, so someone trying to get into their system, every 7 minutes. Every 7 minutes, on average, a company experiences a cyber threat. If those cyber threats are successful, on average, it costs $11 million to a company. And that is not counting the reputational cost of having your systems breached and being the victim of a cyber attack. And many companies don't know that a successful cyber attack has happened. In fact, most don't. On average, it takes 7 to 8 months for a company to even discover that it has been breached in the first place. So cybersecurity is an enormous concern, and it is a concern where we see threats continuing to escalate. Our companies are very committed to providing the most secure software and data services that are possible. They understand and take very seriously that they are information stewards. And by that I mean that they hold and are entrusted with customers' most valuable and often sensitive information. So they take that responsibility very seriously. And in order to earn that trust and keep that trust, BSA members are committed to security by design. Security by design is a term that means that we build and we test and we update security measures at every step when we are developing software. We know that responsibility lies with the software developer to stand behind the trustworthiness of the products. And we also understand that it's critical that there be rapid innovation in security. That's indispensable. Threats to security will continue to evolve in real time, and so security measures to protect them have to as well. It is a fact that security threats do not respect national borders and will not. So we need to have a security policy that can be developed and implemented within an international framework again. We don't need to have different policies in different countries causing fragmenting at national borders. And governments need to give ample breathing room for security technology so that companies can evolve technology based on needs and free from government mandates or interferences in the market. I know that there is much that our companies are doing every day to try to protect against security threats. There clearly is much that companies can do as well to try to protect themselves and protect and prevent and prepare for cyber attacks. And there are things that people in this room can do as well. So I want to talk about that a little bit today. We believe that inside of a company, the most effective cybersecurity comes from the top down, comes from the C-suite. It is far too critical a threat at this point to allow IT departments to be the only line of defense. So while an IT department is certainly your front line of defense, and they can deploy a range of effective securities, they cannot do it alone. Companies need to treat cybersecurity as integral to the overall company's governance strategy. Cyber threats are far too likely and too costly to just be confined to one IT department, including the IT department. Second, management needs to, and employees need to adopt cybersecurity best practices. Now, there are a range of these, which include systematic penetration testing of your systems, making sure you have internal firewalls, making sure you have red flag triggers if certain kinds of information are accessed, making sure that the software patches that you receive are actually received and they are properly installed. It includes understanding your networks, knowing what software is deployed on them, what software is running on them, and whether or not that software is authentic and properly licensed. So taking a holistic approach to cybersecurity and implementing a series of best practices is absolutely critical. And lastly, companies need to be continually reviewing cyber threats. As I mentioned a moment ago, security threats evolve constantly and in real time, and that will not change. And so company practices need to also be constantly evolving to reach new challenges. In this regard, I understand that the AICPA is currently developing a new cybersecurity service that will focus on examining and reporting on a company's cybersecurity internal controls and how effective they are. Such a comprehensive examination from an independent source could provide significant insight and understanding in what is an incredibly complex environment. BSA and our member firms are keenly interested in this endeavor. We see it as an opportunity for the private sector to step forward with innovative tools that are built upon the hallmarks of your profession: independence, objectivity, and integrity. And while there are other services available in the marketplace, many only deal with a subset of the threat environment, and they don't approach the issue at the fundamental level of internal controls, which we believe is critically important. From our perspective, one very important aspect of the examination that you're considering would be to ensure that companies are using properly licensed software. That's because there is a very strong relationship between unlicensed software and the introduction of malware onto a computer network. And of course, malware is one of the things that allows cyber attacks to happen. So we see having genuine, properly licensed software as a first line of defense against cybersecurity attacks. This kind of help, companies, shareholders, and other stakeholders, this is the kind of help that they need in the threat environment that exists today. So we would very much, we appreciate the work and the thought and the leadership that AICPA is putting into this. We believe strongly that we have to continue to develop tools that will evolve, because the cyber threats that we are facing today, as serious as they are, we believe will continue to increase. So turning to the future, on a more optimistic note, software and all the great benefits that it will bring cannot provide the full progress and growth unless we have more computer scientists, more engineers, and more coders. And right now, there is a big disparity between the number of software engineers that we need and the numbers that we have. So the US Department of Labor projects that by 2020, there will be 1.4 million computer specialist job openings. Today, we are only graduating about a third of the graduates that we need to fill those jobs. So there's an enormous disparity between the number of jobs that we have and the number of students that we will have to fill those jobs. Second, in some areas, we are actually going backwards. So in 1984, 37% of computer science graduates were women. In 1984, 37% were women. Today, that has fallen to 18%. In the United States, we are actually going backwards in terms of the number of women that are going into computer science and coding. If we are going to meet the challenges of our age, we have to start by attracting more students and more young professionals into STEM fields and into computer science. We all need to do more. I know you understand the challenges that my industry faces. We share a common bond in that. You are also trying to attract the best and the brightest students to accounting. And you, like us, see the value of working to enhance diversity and inclusion within your profession, just as we do here in software. So my organization, BSA, we sponsored the DC launch of a nonprofit called Girls Who Code. Girls Who Code is a nonprofit. They reach out to young girls to teach them how to code. They have a 7-week summer program, and they had been operating in New York and Seattle and in San Francisco, but they weren't in DC. So we reached out to Girls Who Code and asked them to come to DC, and last year we were very proud to sponsor the DC launch of Girls Who Code. And it's really an incredible program. They reach out to girls from around the DC metropolitan area. They reach out to a very diverse group of girls. Almost all of the girls coming in, virtually all of the girls coming in, have had no exposure to coding at all when they start the 7-week summer program. But by the end of 7 weeks, they have built apps, they have built websites, they have programmed robots to dance. It is incredible what they are able to learn in 7 weeks. And it's really amazing to see them go through the program, not just in terms of the software programs that they build, which are themselves incredible, but in terms of the confidence that they acquire from gaining this new skill. I believe strongly that we need to have more women coders. I think, as I've said, software has enormous promise, but I think in order for software to be as creative and as innovative and as secure as it possibly can be, we need to have more girl coders. So what will these talented coders of tomorrow work on? The promise of software is as limitless as the human mind. From energy to agriculture to molecular science, tomorrow's software developers will be instrumental in opening new paths for innovation. They will be central to saving more lives, to helping grow our economy, and to creating entirely new industries. As I have learned more about the AICPA and your activities in the technology arena, I am convinced that our two organizations can work together to make positive contributions to the challenges of our increasingly interconnected world. The next era of human achievement will be made possible through a combination of talented minds, software, and industries like yours that create with it. The future belongs to the curious and to the imaginative, and people creating with software will create no end of possibilities. Thank you very much.